Hi all, welcome back. So after completing the first lecture, I thought I could actually make some value additions in few of the places. And that's the reason I'm actually not calling this a second session, and I'm calling this as a continuation of the first lecture. So probably this is lecture 1.2, that was part 1, and this is part 2. So I added a couple of slides in between, and I would specifically just take you guys through those particular slides. We saw the prerequisites as part of the first lecture. A quick recap: we saw call option as an upside betting. So if the spot price or if the share price goes above the strike price, the holder of the call option receives the differential. The writer of the call option has to pay the differential. Differential meaning the difference between the spot price and the strike price. If the spot price is less than the strike price, then the holder does not have to pay anything. He all he loses is the initial premium paid. Understanding of put option: it's a downside betting, which means if the spot price the share price goes below the strike price, then the holder of the put option will receive the differential. For example, if the strike price is 100 and if the share price on the expiry date is say 82, then the holder of the put option receives 18. He receives the difference, which is 100 minus 82. The writer of the put option has to pay the holder 18 rupees. If the share price on maturity is greater than 100, which means if the share price, let's say, is 110 or something, then the put lapses. The holder does not receive anything. The loss to the holder is the initial premium paid. Then we saw what put call parity is, where we saw that value of put plus value of share is equal to the value of call plus present value of exercise price. These two portfolios have the same payoff in future irrespective of the share price, and that's the reason both of them need to have the same price today. Otherwise, there will be an arbitrage opportunity. So this is the new slide that I added. I thought it would be more better if I actually first explain the value of an option. Although probably most of you might have already understood, it would. I thought I could make one value addition at this point. So if I quickly run through it. So by value of an option, we mean nothing but the actual premium that the holder should pay to the writer. So for instance, when the contract is beginning, both the holder and the writer will, let's say it's a call option, the holder and the writer are entering into an agreement with a certain strike price, a certain time to maturity. The volatility of the option is also given, and the risk-free rate is also given. Of course, with the current share price also being known. Okay, since option works only on in favor of the holder is required to pay an upfront premium to the writer, right? So when we utter the word value of an option, what we essentially mean is we are calculating the premium that the holder is required to pay to the writer of the option when they enter into the contract, which means when they are entering into the contract, which is on day 0, the holder is required to pay writer the premium. What we are essentially learning in this chapter is how much premium should be paid by the holder to the writer. Okay, so that is what we are actually learning in this chapter. So whenever I say what is the value of an option, we are essentially calculating nothing but what is the premium on the option that needs to be paid. In case of a forward contract or swap, you actually have two separate elements. One is the price of a forward contract, and the other is value of a forward contract. In case of a swap, price is nothing but the fixed rate. So in swap, you have a floating rate or and a fixed rate. So fixed rate is called as the price of the swap. Okay. And then another element that you have is value of the forward contract or value of the swap. So a tip: if you have already done forwards and futures, you would have heard this statement a number of times. The price of a forward contract or a swap is fixed in such a way that the value of forward or swap is 0 to begin with. Okay, so whenever a forward price or futures price or a swap fixed rate is determined, it is determined in such a way that neither the buyer nor the seller are actually at an advantage when the forward contract is beginning. So the value to both the long and to the short, long meaning the buyer and short meaning the seller, is 0 to begin with. Nobody starts with an advantage. Only when the share price or the interest rate starts moving away from where it is currently, one of them stands to gain and the other stands to lose an equal amount. Okay, so in a forward contract and in a swap contract, you have two separate elements, one price and the other value. Value is always zero to begin with. The value starts to have positive or negative value after day one, you know, from when the spot price moves away from where it is right now, or when the interest rate starts to move away from where it is right now. Either the long or the short will have a positive or the negative value. Okay, and price then becomes a historic thing, because price is what you entered it day zero. Okay, price does not keep a price in a forward contract does not keep changing every time, or neither the fixed rate in a swap contract keeps changing every time. It's fixed on day zero. It's the value which keeps changing based on the change in spot rate. However, for options, you do not have price of an option and value of an option as separate things. Price and value for an option are actually one and the same. And the second thing is, options do not have a zero value to begin with. The holder of an option always needs to pay an upfront premium to the writer of the option. In case of a forward contract, since the value to both long and short is actually zero to begin with, nobody is at an advantage, right? So neither the holder pays anything, neither the buyer of a forward contract pays anything to the seller of the forward contract, nor does the seller pay anything to the buyer. Whereas in case of an option, the long actually starts, long meaning the holder of an option already starts with a positive value, which is why he pays an upfront premium to the seller of the option. Okay. And how much premium should the holder pay to the writer is what we are discussing as part of this chapter, which is valuation of an option. Okay, so whenever we value a call option, and let's say the value of a call option today is determined to be 10 rupees, that means the holder should pay to the seller 10 rupees upon entering into the contract today. If the value of can the value of an option actually be negative? The answer is no. Value of an option will either be zero or greater than zero, right? So the essence of what I want, the essence of or what I wanted to convey here was, value of an option and price of an option are one and the same. In case of forward and swaps, price and value are two different things. Now that is number one. Number two, value is nothing but the premium that the holder is required to pay to the seller or the writer of an option at the beginning of the contract. Okay, so we are in this chapter, what we are essentially doing is nothing but calculating the amount of premium that needs to be paid. Next, we saw the methods of option valuation, meaning the single period binomial model, two period binomial model. Within the single period, we saw that there's delta hedging approach, portfolio replication approach, and risk neutral valuation. There's no addition that I made over here. And then by a two period binomial, 3 period, 4 period binomial, etc. And then we go, when the number of periods tend towards infinity, we then arrive at something called as the Black-Scholes-Merton model, which is a Nobel Prize winning model, and it's a closed form solution of option valuation. So basically, Black-Scholes will throw a formula to you. It won't explain you what the underlying formula is doing, but when you input the numbers into that formula, you get an output, and the output is nothing but the premium that the holder should pay to the writer. That premium can be calculated for call option as well as for put option. This is again another slide that I actually added. So for those of you who would, I mean, in all likelihood, you might have already completed share valuation and bond valuation. Over there, you actually read that, you know, there are basically there's one school of thought which talks about discounted cash flow valuation. The question it asks is, how much are you willing to pay for an asset? The answer to that will be, you're willing to pay for an asset to the extent it benefits you. For instance, when you're buying a car, the maximum value that you will pay to the car is only to the extent it benefits you. When you're buying a house property, the same is the case. To the extent the house property benefits you, you will pay the, I mean, to that extent, you will be willing to pay as the purchase price for that house. Okay. So the definition as per this school of thought is that value of an asset is the present value of future benefits discounted at the required rate of return. Future benefits is always measured as cash flows. You have seen right from CA Inter or CFA level 1 that, you know, benefits are always calculated in terms of cash flows, whether it's in capital budgeting or anywhere. You always look at benefits in form of cash flows and not as profits. Okay, for example, if you're buying a house property, the future benefit is the rent that you receive from the house property and the expected sale proceeds whenever you intend to sell the house property. In case of a share, the expected cash flows are dividends and the expected sale price whenever you sell the share, or you can use the free cash flow method as well. In case of bond, the expected cash flows are coupons and the face value of the bond. Now coming to why do we take a present value? This is a basic question. Obviously, it's because of time value of money. Rupee 1 received today is not equal to rupee 1 received 1 year later. The rupee 1 received today has got more value than the rupee 1 which is received later on, right? So that is the reason you actually have to discount. The rupee 1 received later is equal to say 0.9 or 0.95 in today's terms based on the discount factor that you apply. Now, what are the few, in case of option valuation, what are the future cash flows? Future cash flow in option valuation is nothing but the payoff from an option. For instance, if I come back to the Excel file where we took an example in the previous lecture, I added the column E for another purpose. So let's now look at only up to column D. From column B to column D, it's a call option. Just to recap, the strike price was 48. The current spot price at T equal to 0 was 50. We said that the share price can take two values, one 55 at the end of 6 months. This is at the upper node, and the other possible price at the end of the 6 months is 45, which is at the bottom node. And this we arrived as by multiplying it by U and D respectively. We multiplied the current share price by U to get the upper node and the current share price by D to get the downside node. Okay. Now the payoff from an option, we saw that if the strike price is 48 and at the maturity, the spot price or the share price is 55, then the payoff from a call option is 7. If the share price on maturity is 45, the payoff from a call option is 0 because the future spot price is less than the strike price. Therefore, the holder of the option does not receive anything. He does not have to pay anything as well. Okay. So if I try to apply the school of thought that discounted cash flow valuation is doing, it says the present value of expected of future cash flows, right? The future cash flows could be either 7 or it could be 0, right? Now, obviously, when there are two possibilities, you end up assigning probabilities and you arrive at the expected cash flow by multiplying the probability. For instance, if the upside probability is 0.6, the downside probability has to be 0.4 so that the total probability is equal to 1. So the expected cash flow will be arrived at as 0.6 into 7, which is 0.42, plus 0.4 into 0, which is 0. So the expected cash flow from the call option or the expected benefit from the call option is 0.42, which is nothing but 0.6 into 7. Oh, sorry, it's 4.2, my bad. Right? So now coming back to the discounted cash flow valuation, it says the value of an asset, over here we're talking about option, is the present value of future cash flows discounted at the required rate of return. The present, okay, now we can basically, we have calculated what the future benefit is. We have calculated the future benefit to be 4.2, right? Now we need to take the present value, and to take the present value, we need to arrive at the required rate of return. Okay. Now, the reason why we actually do not apply the discounted cash flow valuation and instead we actually apply the methods of valuation that we saw over here and the Black-Scholes model, Black-Scholes model wouldn't have actually won a Nobel Prize had it been as simple as, calculating the future cash flows and calculating the expected payoff from that and discounting it at the required rate of return, right? The problem is we do not have a model to actually find the required rate of return for an option. Like we have CAPM or arbitrage pricing theory for calculating the required rate of return for shares. We do not have a model to calculate the required rate of return for an option because each asset is going to have a risk which is completely specific to it. Okay, bonds have a particular type of risk, shares have a particular type of risk, futures have a different set of risk, options have a different set of risk. We currently do not have any model which is capable of actually finding out the required rate of return given the risk involved in the options, right? So, I mean, CAPM and APT are absolutely applicable purely from shares perspective. So we actually cannot use CAPM or APT as the discount rate to calculate the present value for options, for option payoffs. Okay. Obviously, but if you actually look at it, the payoff of 4.2, the expected payoff that we arrived at 4.2 is actually not a risk-free payoff. It has an element of risk. Okay. Risk is stemming from the fact that your payoff could be either 7 or it could be either 0, which means the payoff is actually uncertain, correct? We are assigning probabilities to it and then calculating an expected cash flow of 4.2. But that 4.2 is not a risk-free cash flow, right? So essentially, what we know is the required rate of return is supposed to be something more than the risk-free rate, okay? Because the cash flows are risky, but we do not have any model which is capable of capturing the risk that is involved in options. Beta, which we calculate for CAPM and APT, is purely applicable for calculating the systematic risk involved in a share. Okay, it cannot be used for calculating the risk involved in an option. Okay, so now the biggest problem that we have is, although we are able to measure the future benefit, we do not have a discount rate to actually discount these future cash flows. And discounting obviously is a very integral part of valuation. Like you must have known, like, change in discount factors, can take your valuation either completely upside or downside. So obviously, let's not say that, let's not apply discounting factor at all. 4.2 is the value of option. No, that's not right. 4.2 is the expected cash flow at t equal to 6. You're supposed to discount the expected cash flow to today's terms, taking into consideration, one, that obviously there's a period of 6 months in between, and two, giving weightage to the fact that the 4.2 is not a riskless cash flow, but it is a risky cash flow. And now, because you're not able to apply the discounted cash flow valuation, we are resorting to alternative methods. And the alternative methods are nothing but what we actually saw in the previous section, which is the single period binomial model. We have delta hedging, portfolio replication, risk neutral valuation, and then 2 period, 3, 4, and Black-Scholes model. So now we are actually resorting to alternative methods to valuing options, and we are going to learn those alternative methods. Okay, so now I've actually set a tone that the problem with option valuation is actually finding the discount rate. Okay, so in all the methods that we actually try to see, we look for trying to build alternatives, okay, so that we do not actually use a risky rate of return. You know that the required rate of return, if you're trying to value an option from a without from in the discounted cash flow valuation school of thought, you need a risky discount rate. We are now going to try and avoid arriving at that position where we need a risky discount rate. Okay, I cannot really elaborate more than this given the current scenario, but have this background in your head saying that we cannot use the risky discount rate, and to avoid arriving at a position where we are supposed to use the risky discount rate, we're actually going to find alternatives. Okay, instead of using the risky discount rate, what else can we use instead of discounting the risky cash flow with a risky discount rate, or a discount rate which has risk embedded in it. That is what I meant by risky discount rate. Okay, and then we saw what a slope is. In a straight line equation where y equal to mx plus c, m refers to the slope. The meaning of m is, if x goes up by 1 unit, how much does y go up by? Sorry guys, just give me a minute. Yeah. So the meaning of slope is, if x goes up by 1 unit, how much does y go up by? And we then took an example of total cost equal to variable cost plus fixed cost, etc. The meaning of intercept is nothing but, if x is equal to 0, y will still have a value. What is that value of y? We saw that this basically denotes the fixed cost out of the total cost. The meaning of intercept is not really relevant, at least from, in option valuation chapter, we're going to completely dig into slope. Okay, and then slope can also be calculated where you have 2 points, x1, y1 and x2, y2. The slope can be calculated as y2 minus y1 divided by x2 minus x1. This is what we actually used over here. I'll come back to the Excel file in a minute. But yeah, this is the formula basically that we actually used. Okay, but this can also be used only where you have 2 points, x1, y1 and x2, y2, and it's actually a straight line equation. And then we saw that for the math freaks, which involves differentiation, slope is actually the first derivative, not the SFM derivative, but the math derivative of any equation. For instance, if we have the equation y equal to 7x plus 50,000, and if you differentiate this by x with x, then you, on the left hand side, you have dy by dx is equal to d by dx of 7x, d by dx of ax, where a is a constant, d by dx of ax is equal to a. Okay, so that is why we have 7, and d by dx of any constant, d by dx of a is actually equal to 0. So 7 plus 0, which is equal to 7, right? So dy by dx is actually equal to 7. Dy by dx is nothing but the slope. So, which is nothing but 7 over here, right? So slope is equal to 7. Again, the meaning of slope, if x goes up by 1 unit, how much does y go up by? And then we actually started the delta neutral method, or the delta hedging approach within the single period. And we saw that delta is actually nothing but the slope of an option. So option is a dependent variable, share is an independent variable. Option is deriving its value from the share, right? So option is a dependent variable. So the option valuation also has an equation, which we did not see. That equation is nothing but the Black-Scholes equation. But when we are looking at the single period binomial model, it's basically a straight line equation, because we are saying that there are only 2 points, x1, y1, x2, y2, right? So it becomes a straight line. The share, so what we said was delta refers to when share price goes up by $1, or when share price changes by $1, either on the upside or the downside, how much does the option price change by, right? That is called as delta. And this was nothing but the sorry. So this was nothing but the meaning of the definition of slope as well, right? When the independent variable changes by 1 unit, how much does the dependent variable change by, right? So delta is nothing but the slope of value of an option. And then we saw that what beta is for share, delta and duration is for bonds, delta is that for options. Okay, and then we saw that delta by itself is not constant. Delta itself keeps changing based on the change in share price. I would like to actually come back to the 2 period or okay, maybe let's stick with single period binomial model. I'm not talking about this statement. We'll come back to this statement. I'm just first now covering what delta is, so that we again refresh the example that we had in first 4 point. In the previous lecture. So we saw that the current share price is 50. The potential share price could be either 55 or 45, and the potential payoff from a call option could be either 7 or 0. So the payoff from a call option is y, and the payoff from and the share price is actually x, right? So this one is x1 y1, and this is x2 y2, and we calculated the delta of the option as y2 minus y1, which is nothing but 0 minus 7 divided by x2 minus x1, which is 45 minus 55, which is nothing but minus 7 divided by minus 10, which is 0.7. You can actually even take this as x2 y2 and this as x1 y1. You will still arrive at the same. You'll be 7 divided by 7 instead of minus 7 divided by minus 10. Now the addition that I wanted to cover was delta of a put option. So the delta of a put option is also again calculated. So what I essentially did over here was I calculated the payoff from a put option if the share price in future is 55. If the strike price is 48 and the share price is above the strike price, the put option actually lapses. So the holder does not receive any amount. So the payoff from a put option is actually 0. On the downside, the strike price is 48. The share price is below the strike price, and the payoff to the holder is actually 3 rupees or $3. So the writer will pay to the holder 3 rupees on payoff, right? So over here, 55 and 0 are x1, y1. The put option is nothing but y1, because the put derives its value from the share. So put option is y, the share price is x. So share price is X1. The put value of 0 is Y1. On the downside, the share price is X2 and the put option price is Y2, right? So the coordinate points, if you're able to imagine, is 55, 0 and 45, 3. Now calculate the delta using the same formula. It is equal to Y2 minus Y1, which is 3 minus 0, the whole divided by X2 minus X1, which is 45 minus 55. The delta of a put option is equal to minus 0.3. Okay, the signage is actually correct. Okay, I did not make any mistake. The delta of a call option is positive 0.7. The delta of a put option is negative 0.3. Okay, now actually come back to the definition of delta. What we said was delta means if the share price changes by $1, what will the how much will the option price change by, right? So now let's say the share price basically over here, obviously there are only two share prices, right? It can either be 45 or it can be 55. Okay, so let's say the share price changes from 45 to 55. So the share price is increasing by $10, right? The payoff from call is increasing by from 0 to 7. So when the share price is increasing by $10, the price, the put option payoff is, sorry, the call option payoff is increasing by $7. Okay, sorry if I said put earlier. Whenever I'm referring to $7, it is call. 0 and 3 is put. Okay, so $10 increase in share price is increasing the call option by $7, right? So for $1 increase in share price, the change in call option or the increase in call option is 0.7. That's a simple. Give me a minute. Sorry. So that's a simple mathematics, right? For $10 increase, you have $7 increase in call price. So for $1, how much? It is 0.7, right? 7 divided by 10. Okay. This positive coefficient over here indicates a direct relationship between share price and the value of call option. What do we mean by direct relationship? If the share price goes up, the call also goes up. If the share price falls, the call also falls. So over here, if the share price increases from 45 to 55, the call option increases from 0 to 7, right? So if when the share price goes up by $1, the call option goes up by $0.7. If the share price falls by $1, the call option falls by $0.7. Okay, that is the meaning of positive coefficient, right? They move in the same they move in the same direction. They have a direct relationship between one another. Now the negative in the put option indicates a negative correlation between the two of them, which means if the share price increases by $1, the put option falls by falls by $3.3. When I use the word fall, I should not again attach the minus sign to it, right? So if the share price goes up by $1, the put option falls by $0.3. If the share falls by $1, the put goes up by $0.3. So there is a negative relationship between share and the put option. Obviously, that is intuitive as well, right? So let's say, forgetting this example, let's say there is an option whose strike price is, let's say, 100 and the spot price is 105. Okay, so the option right now is actually out of the money. So if the share price increases from 105 to 110, let's say it increases by $5, the put option, which is having a strike price of 100, becomes even less worthy, right? Because I mean, now it is furthermore out of the money, right? So the value of the put option has to fall. So when the share price goes up, the value of the put falls. Similarly, if you actually think of call option, if you have a strike price of 100 and the current spot price is 105, and that 105 actually increases to 110, then the strike at 100 and the 100 rupees, the 100 strike call option has now become much better. Earlier it was 5 rupees in the money. Now it is 10 rupees in the money. So it is a much better call, right? So the premium for this call actually increases, right? So when the share price goes up, the premium for a call option is also going up, indicating a direct relationship. Okay, and then we saw delta is not constant. Okay, I'm repeating the example, but a little quickly. So we saw that in a single period binomial, the delta is 0.7 for a call and minus 0.3 for a put option. Okay. Uh, okay. One point that I wanted to also mention was dropping the signage, which means taking absolute value, which is modulus of delta of call plus modulus of delta of put, is always going to be equal to 1 for a non-dividend paying share. So if you have a non-dividend paying share, the delta of the modulus of delta of a call plus modulus of delta of a put is going to be equal to 1, which is the case over here. 0.7 plus 0.3 is equal to 1. Okay. Now coming to here, we saw that when when the share price is actually 55, so at t equal to 0 the share price was 50. At t equal to 3, let's say the share price is increased from 50 to 55, we saw that the delta of the call option has become 1, right? The way we calculated was, again, this was taken as x1 by 1, this was taken as x2 by 2. So we had 12.5 minus 1.5, or actually we took the other way around. The bottom one was taken as x1 by 1 and this one was taken as x2 by 2. So we have 12.5 minus 1.5, which is 10, divided by, which is 11, divided by 60.5 minus 49.5, and we got 1 as the delta of call option, which is 11 by 11, right? However, when the share price actually falls from 50 to 45 at t equal to 3, the delta of the call option was 0.17. Okay. Obviously, given the rule that I actually just gave you, that the modulus of delta of a call is plus the modulus of delta of put is equal to 1. If the delta of call is 1 on the upper side, the delta of put should obviously be 0. And over here, it will be equal to 1 minus this, right? So what we are saying is, if the share price, sorry, I think there was a disturbance. So what we were saying was, if the share price actually goes up from 50 to 55, the delta of that we earlier saw was 0.7 and minus 0.3. Over here, the delta of a call has become 1. It has increased from 0.7 to 1, and the delta has fallen, or rather delta of a put has also increased because it increased from minus 0.3 to 0. I mean, mathematically it's an increase, although if you drop the negative signage, it will look like a fall, but mathematically it has increased from minus 0.3 to 0. Okay. Over here it's supposed to be minus 0.833. When the share price falls from 50 to 45, we saw that the delta of a call has also fallen from 0.7 to 0.1. And over here, the delta of a put has also fallen from minus 0.3 to minus 0.833. If you drop the negative signage, magnitude wise, it has increased from 0.3 to 0.833. Including the negative signage, it has actually fallen, right? So when I said that the delta is actually not constant, the delta keeps changing based on the change in share price. Why did the delta actually change over here? The delta has changed only because of one reason, which is nothing but the share price changed from 50 to 55 or 50 to 45 as the case may be. So the delta itself keeps changing when the share price changes. Okay, so if I actually again revise, delta refers to what is the change in the value of an option for a given change in share price, which means if the share price increases by $1, a delta of 0.7 means the call option value will increase by 0.7. Okay, but when the share price changes by $1, the call option also the call option changes by $0.7. In addition to that, the delta also increases from 0.7 to 1 in this case, right? So I mean, over here, of course, it has increased from 50 to 55. It was not a $1 increase, but basically the delta will keep moving from 0.7 to 0.8, 0.8 to 0.9 for an increase. Okay, for a decrease, it's going to fall from 0.7 to 0.6, 0.5, 0.4, that way. Okay. Next. So the delta itself keeps changing. you will actually, maybe from a CA final perspective, you will probably not really dig further into it. But for CFA and FRM, you're going to have option Greeks where you will talk about this change in delta as well. Okay. I remember that in the previous lecture, I compared this change in delta to nothing but a change in duration, like how for duration, like how for bonds, duration itself keeps changing. Similarly, for options, delta itself keeps changing. Okay, we calculated the example, fine. Now this is again a new slide that I've added. A little more about delta. A delta of a call option always lies between 0 and 1. Positive implies a direct relationship, which means the call option value and the share price, they move in tandem when both of them increase or both of them decrease. They have a positive correlation. The delta of a put option lies between -1 and 0. So over here, when we saw in the two-period binomial model, the call option reached its maximum delta of 1. The put option reached again its maximum delta of 0, right? Okay, over here, the call option did not reach, I mean, it was between 0 and 1. The put option delta was between -1 and 0. Okay, deep in the money options have delta close to 1 in case of a call option or -1 in case of a put option. So over here, if you actually see, the strike price was 48. The share price at t equal to 3 was 55. Okay. And at t equal to 6, the option was certain to mature. They're certain to have a positive payoff, right? Because it was certain to get exercised. Because even at upper node, the option has a positive payoff. At the bottom node also, the option has a positive payoff of 1.5. So the option was virtually certain, right? So when an option is certain to actually get exercised, any movement in, so it's a deep in the money call option, which means it has a very low probability of going out of the money, right? It can, in real world, share prices can go crashing anywhere. So it can, but as of now, it's a deep in the money call option. Okay. A deep in the money call option has a delta equal to 1. Had it been a deep in the money put option, it would have a delta of -1. We don't have an illustration, but had this strike price, let's say, been about 70, and these are the future possible payoffs, then the put option would have had a delta of -1. Okay. And deep out of the money options have a delta close to 0. The put option over here has become deep out of the money, provided at t equal to 3, it is 55. Yeah, I'm talking about a situation where at t equal to 3, the share price is 55, and at t equal to 6, there are two possible payoffs, right? I'm not talking about the scenario where at t equal to 3, the share price is 45. I'm not talking about that scenario. Okay, so if the strike price is 48, it is evident that the share price at t equal to 6 cannot fall below 48, right? So this is virtually a deep out of the money put option, and the deep out of the money put option has a value of has a delta of 0. An easier way to actually think of it is, if you forget the binomial example, just think of an example like this. Let's say there is a strike price of $500. And sorry, I'll just switch the amounts. Let's say the spot price is okay. Okay, let's take an example of a call option whose strike price is 500. The reason I actually was about to change was because I was talking in put option and these figures did not make sense for a put option. But if we think for a call option, these figures will absolutely make sense. Let's say there is a call option of strike price is 500. So when is the call actually going to give a payoff? If the spot price is greater than 500, the holder will actually get a positive payoff. Now, let's say the spot price is actually $100. Okay. So for the holder to actually get a payoff, the spot price needs to move up by $400, right? In 3 months, which is almost, it can have a probability, but it is virtually a very, 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 very low probability event, right? So now let's say the spot price has increased from 100 to 101. Okay. Do you think that the call option value will also increase from, let's say the call price right now is maybe $1. Okay. or $1 might actually, okay, fine. Let's say it's $1 and the share price has increased from 100 to 110. It has moved up by $10. Okay. Is this $1 actually going, is the value of the call option, is that going to increase from $1 to $2? The answer is no, because that the increase from, sorry, is it going, the question should be whether, one second. Yeah, sorry for that break. Um, Revisiting the example, the strike price was 500. The spot price is $100. Let's say the current share premium is $1, right? So if the share price goes up from 100 to 101, the call option will not increase from $1 to $2, because that call option, to have a positive payoff, to have some value to the holder, it should go up by $400, right? So it is virtually a improbable event. So the $1 call option will move from 1 to 1.01, right? So the delta is actually going to be completely almost tending towards zero. At the money options have a delta of 0.5 or minus 0.5. Minus 0.5 for put option, 0.5 for call option. Okay. And I don't know if this hit you already, but delta is often looked at as the probability of exercise of the option. For example, we saw, it's a vague definition. It's not an appropriate definition, appropriate understanding, but a deep in the money call option has a delta of 1, which means the probability of exercise of that option is close to 1. And the probability of exercise of a put option, where the put option is deep out of the money, is 0. Over here, the probability can be thought of as 0.17, and the probability of a put being exercised can be thought of as 0.83. Obviously, it's not negative 0.83, it's positive 0.83, right? So when the share price increases from 50 to 55, the probability of the call getting exercised also increases, and that is the reason the delta also keeps increasing. Because if you look at delta as the probability, delta is increasing because the probability is increasing. But of course, it's a very it's not an correct way to look at it. The true meaning of delta is nothing but its relationship with the share price. If you guys have not really understood this part perfectly, I think that's still okay, because it's not relevant at this point. When we look at the Black-Scholes model and when we dig into option Greeks, you will have to understand this, and over there you will understand it because of the relevant examples that we take. But I think this must be understood very well. Sorry again for this bad usage of pen. The delta of a call option is 0 and 1, and it is positive, indicating a direct relationship. Delta of a put option lies between -1 and 0, indicating negative relationship. Okay, I think I will stop this video over here. We'll continue with the second lecture, wherein we'll start with delta neutral method. Again, that's going to run for about maybe half an hour, 45 minutes. I don't want to continue that as part of this lecture. This lecture, we'll end it as lecture 1.2. All right. Thank you, guys.